All right, so in the last set of videos, we basically start talking about what differential equations are. So I'm just gonna quickly recap the stuff that he went over. So the first thing is the distinction between just a basic algebraic equation versus a differential equation, and you can see from the examples here, just kind of like how just in what ways they look different. So in algebraic equation, there are variables that where you can solve for example, like x squared minus x plus 6 equals 0, and then the goal is to basically solve for what values of x satisfy the equation. Whereas in a differential equation, the only main difference is that now you have to deal with the degrees of derivatives of different variables. So in this example, we have y, but we also have y prime and also y double prime. But the basic idea is still the same. You want to solve for the equation, the y, the equation that actually satisfies satisfy all these conditions. So in this example, it's e to the negative 2x that makes this thing true. So some key points to remember is that for a differential equation, there are infinitely many solutions, but the solution is always a function. An important detail about differential equations is the order. So that just means what the highest power is in not the highest power, the highest degree of derivative. So the first order would mean that the first derivative is the highest. I don't know if highest is, yeah, I guess highest is the technical term. So the first derivative is the highest order derivative, and then you can have like a second order derivative where the second derivative is the higher derivative, and so on and so forth. So you can have y to the nth order derivative, and that's going to be the nth order. And this is just an example. He gave an example on how we can use this to model like data. And his example was about the population of deer, but we're not going to really go into that. And then finally, he introduces this concept of like slope fields. So slope fields essentially give you an idea of what the potential functions can look like, because we said before, in a differential equation, there are infinite many solutions. So slope fields give you an idea of what these infinite many solutions could take the form of. So an equation like this, basically what you do is you plug in y values, and then whatever value you get, that is the derivative at that y value. So for example, if we take 2, right? So 2 minus 2 is 0, multiplied by whatever is going to be 0. So when y equals 2, the derivative is 0. So at all these points, you're going to have a horizontal line because the derivative is just 0. And then here's another example that he showed where it involves both x and y. So if y at the point 1, 1, y equals 1, x equals 1. 1 plus 1 equals 2. So at the point 1, 1, the slope of the point is going to be 2. And so you can just take that and apply it to the rest of the coordinate plane. And essentially, you just do the same thing. You just take the input, whatever the one side equals, the other side, the slope of the solution of one side, the solution of one side tells you the point or the wherever axis you're looking at, and then that solution tells you what the slope is at those points, essentially. So let's go into these example questions and try to sketch the slope fields. Can someone like pull up the? Oh, I just realized I didn't even share my screen. Yeah, cool. So let's keep going. So does anyone want to share the screen and show the whiteboard? Or I mean I could do it too.
So if you share your whiteboard,
Oh, right, everyone can
you
write into
can
it.
draw and everyone can annotate, so it could be collaborative.
Yeah. Google Chrome. Yeah, actually, I'm just gonna go back to what I was showing earlier. I forgot, I didn't realize that I didn't share my screen. Yeah, so the only one that we need to visualize is the concept of slope fields. So if you're, for example, in this one, at the point 1, 1, you add y and x, so 1 plus 1 is 2, so which means at this point 1, 1, the slope is going to be 2. So it's like an upward sloping thing. And then that's kind of the basic concept you apply for the rest of the coordinate plane. So are there any questions at this moment? All right, so let's try to sketch the slope fields for these equations then. Let's see, how should I do this? You can share a whiteboard, right? Share whiteboard, yeah. Okay, so if anyone wants to write, because I only have a trackpad, does anyone have a mouse?
go ahead. Why don't you start off? I was doing with a trackpad earlier, and it's doable.
The
A little annoying.
y over dx equals x minus y. Okay, so if we have this, then draw the grid. All right, so if we do 0, 0, basically here all the diagonal ones are going to be 0 because anything minus itself is going to be 0. So at 1, 1, it's going to look like this. 2, 2, it's going to look like this. 3, 3 is going to look like this. 4, 4, etc., etc. They're all just going to be, yeah. And then if we have a -1 minus a -1, that would also equal 0.
Mm-hmm.
So all of these would be horizontal.
Mm-hmm.
So 1, 2, 3, 4, 5. Yeah. And then if we have, for example, 1, 2, then x is 1, y is 2. Then we have a negative. So 1 minus 2 would be a -1. How would this differ? And then 1 minus 3 would be -2. So you just have slopes that are becoming more and more vertical. And I guess the same thing applies for all the rest of them. So 2 minus 1 would still be positive. So that would still be a 1. But then 2 minus 3 would start becoming negative. So -1. And then the same thing applies again. As the y's increase, you're going to get more and more, the slope becomes more and more negative. So I'm just going to try to do this box here because that's kind of a lot to all draw out. And then we can have 3 minus 1, which would be a 2, so that's still positive. Going to be positive. And then 3 minus 2 is going to be 1. That's also going to be positive. So basically anything under this horizontal line is going to be positive, and everything above this horizontal line is going to be negative. And then we have 4 minus 1, which is 3, still positive. And then 5 minus 1 is 4, which is also positive. But yeah, so they're all going to be positive. Let's see. It's going to become less positive. This is so messy. Less positive. Less positive. All right, but you get the basic idea. So yeah. More negative, more negative, more negative, more negative. If I were better at drawing this, we could actually see something. But I guess you could technically trace out what an equation could look like because Let me try to change the color here. Oh, I changed the color. Oh, okay. So if we take one example, maybe you could draw something out like, fuck. All right, you can draw something out like this, but basically you get the idea. You can connect these slopes, these
Yeah.
very small like intervals of slopes, and then you eventually get things that look like actual equations, and those are are part of the infinite many solutions that you have for the differential equation.